Hello, all right. Today we're going to be talking about the law of cosines. Now, the law of cosines is still used to solve triangles, and we only use it if usually we only use it if the law of sines doesn't work. And I've drawn two examples of triangles here where if you tried to solve them, the law of sines would not work. Because to do the law of sines, you have to have at least one pair of partners. As I said, partners are the angle and the side that are across from each other. And here's this angle, and its partner's gone. This side has its angle gone, and this side has its angle gone. So this one, you can't use the law of sines to start it. And this one, these are all sides. That's 7.2, because they can be decimals. And none of these have an angle at all. So none of these have a partner either. So the law of sines does not apply to either of these, all right? So when you're and so this is actually technically what's called the SAS case, right? And this is the side case, right? So many websites will refer to that. So SAS and SSS don't work for law of sine, right? They just can't work, but they can work for the law of cosine. All right, the law of cosine relates actually 4 bits of information. Right, the 4 bits that it relates, all right, is an angle, and well, B and C, but this angle, right, whatever it is, and then this is side B, C, and A. So if you have an angle and 2 sides, and the angle across from it, all right? So those are 4 bits of everything I circled are the things that you have to know at least 3 out of the 4 from that, right? Basically, that's SAS, right? Because you know these 3, but you're missing this one. And over here, you know these 3, but you're missing this one. So, and this is only going to happen when the law of sines doesn't work, all right? So you don't have to really think about this too hard. You try the law of sines and you say, hey, I haven't got any partners. So if that's your situation and you say, oh my gosh, I don't have any partners, then pretty much you're stuck with the law of cosines, right? So the law of cosines would work on this triangle, and sometimes just say LOC for short, right? And LOS for law of sine, right? So these actually would have to be started with the law of cosines. Now, unfortunately, the rule for the law of cosines is actually a little bit long, so a lot of students don't like to see it, right? But we have to do it. So the law of cosines is this formula here, because I said you have to know at least 3 sides and an angle. You have to know 3 out of these 4, because if you know 3 of them, if only one of these is missing, you can solve for the 4th. So we're going to have all 3 of these pieces involved in the formula for the law of cosine. Now, there's actually some variations on it, but I'm going to show you the one that's probably most common to you, right? Or easier for you to memorize. The side c squared, these are all sides, equals side a squared plus v squared minus 2 times side A times side B times the cosine of angle C. All right, that's a B there. All right, so the C's are at the ends of the 2 ends. That's the side C, and that's the angle C. The angle has to be with the cosine. Okay, so that is your law of cosine. Most students are like, oh my gosh, this sucks. But actually, notice if you cover this up, what do you have? The Pythagorean theorem. So this is actually just, and you just take the same 2 letters from the Pythagorean theorem and do a -2 and multiply the same 2 letters and the cosine of this. That the ends are always the same letter. Okay, and actually, when you really think about it, there's some websites or books call this the general Pythagorean theorem, because if C is 90 degrees, what's the cosine of 90 degrees? Well, it's 0, and all of this would just cancel out, and you're left with the Pythagorean theorem. So this is kind of like the Pythagorean theorem for any triangle, even if it's not necessarily a 90-degree triangle. Now, some people are like, well, that's great if the side I'm missing is the C side. What if I'm missing the B side? Well, you can do this for anyone. So if you're, well, actually, let's say with the A side, say you're missing the A side, then you say A side equals the other 2 sides, B squared plus C squared, minus 2 times these 2 sides again, BC, times the cosine of what you started with, A. All right, remember the ends are always the same. The ends are partners, side angle, angle. And of course, you do this. You could do it again if you're missing side B. It's b squared equals the other two sides, a squared plus c squared, minus those two sides again, 2 times those two sides, times cosine of, bookends are the same, b. So you'll see sometimes 3 different versions of the law of cosines. They're all kind of the same thing. It's just keeping in mind that the partners are at the ends. They're out across from each other. So as long as you keep that in mind, and everything else are the other two sides, right? A squared b squared, ab. B squared c squared, 2bc. A squared plus c squared, 2ac. Everything is, there's kind of a pattern there. So that makes it not as bad to memorize as you would think. And keep in mind, if you know, so generally if you're missing this side, you put at this end. If you're missing the ace, you put at the end. You could have it in the middle, but it's a little bit easier. Sometimes you're missing the angle, but if you know all these other numbers, you can technically solve it. And we'll see some examples of that actually right about now. Okay, so I have this worksheet from another book. So we're going to do 2 examples. We're going to do number 6 and number 9. So let's start with number 6 right now. Actually, let's get the paper out. Okay, so we're going to solve the triangle. We're going to ignore it. Well, actually, we're going to do these same directions. Now, on the test, I might not say use the law of sines or cosines. It'll just say solve the triangle. So you have to know which rule to do. And if I were looking at triangle 6, number 6, I would say, well, and let's look, always look for law of sines first. Look for partners, but B doesn't have its partner. A doesn't have a complete partner, and neither does C. So I would just look at number 6. Even if this part weren't here, and that was crossed off, and I just said solve, I still could not use the law of sines. I would be stuck. So that if I'm stuck, I try the law of cosines. Now, since I know these 3, look for the one across, right? I know B, so I'm trying to find side B, because I already know side C and A, right? That's side C, I already know it. I already know side A. The side I'm missing is B. So let's solve for B. Now, the formula is b squared equals the other two sides. Now, their sides are 10 and 16. So b squared equals 10 squared plus 16 squared minus 2 times 10 times 16 times the cosine of b, which is 40. We do know that. So that's how we start this equation. I'm going to take this away for now so we can just actually focus on solving that equation. Okay, now I'm definitely going to need a calculator to do this. You really need a calculator. So b squared equals, and actually, if you're really clever, you can do all of this in one step. Some people actually work out 10 squared plus 16 and then just put it in their calculator. The scientific ones can usually do all in one step. So I'm going to try to do this all in one step. So 10 squared. My calculator actually has a squared button, so I just hit the squared button. Yours may or may not, so it depends on your calculator. Plus 16 squared minus 2 times 10 times 16 times the cosine of 40. Make sure you're in degree mode. So that's everything from here, and I just hit enter, and I get 110 points. Well, I guess 9 if you want to round it. Okay. Now, here's the thing, got to think, be careful. That's not my final answer because that's my answer to b squared. So to solve for b, I still need to take the square root of both sides. So b equals the square root of that answer. So square root of that answer, and I get 10 point approximately 5. Right? And I don't believe, well, there were some units. There's in kilometers. We're doing this problem. There's in kilometers. Now, sometimes there's units, sometimes there's not. There's no units, don't worry. But that is my answer for B, 10.5 kilometers. So there you go, 10.5 kilometers. The formula is a lot of work. Right? That's a lot you have to type in. But if you have a calculator, and a pretty good scientific calculator, sometimes you do it all in one step. Some other calculators, you might have to just do 10 squared, 10 times 10, and then minus on that 16 times 16, and then minus that from 2, and you might have to enter it individually. So it just depends on your calculator. Try some sample problems, and if your calculator gets the same answer, then you're good. Okay. Now we're still not done because I still don't know angle A or angle C. Right? But here's some good news. I now have a partner. All right. So I use the law of cosine to get this, but now to get the others, I can actually mix it up and use a law of sines. Right. So I'm going to say that the sine, so for the rest of this, I'm going to say the sine of 40 degrees, right, B's angle, over 10.5 equals whatever angle I want to solve for. I can solve for A because it's missing one part, or C because it's missing one part. Let's go for A. So the sine of A, now I don't know what A is. So sine of A, I don't know what A is, but its partner is 16. So you can mix it up. So now that you know both rules, usually you only use law of cosine once to get you started. And then once you get that first missing piece, you can usually just finish it up with the law of sines. All right. So I'm going to solve for A. I'm going to multiply both sides by 16. I think I got cancel. So I get 16 times the sine of 40 degrees over 10.5 equals the sine of A. Right, now I got to get out my calculator, right, and actually work all that out. So 16 times the sine of 40. I like to do the top part, then divide it by 10.5, and I get 0.9795 if I want to round it, equals the sine of A. Now that's not the angle, because that's the sine of A. How do I get rid of, just need to find just A, so I need to get rid of this sine. And you can't just divide sines. What I said earlier is the opposite of sine is the inverse sine. So I'm going to take the inverse sine of both sides. And sines and inverse sines, that cancels. So A is going to equal the inverse sine of that, the inverse sine of, and I'm going to use the answer button so I get more exact, because then it won't round it. If you round it, that's fine too. Just know that your answer might be off by a decimal place or so, but I got 78.37. I'll round it to 4. And this is an angle, so it's in degrees. All right, so 78.4 degrees. Now, if you rounded it, you might get 78.5 or 0.3. You might be off by a degree, by a tenth, and that's just due to rounding, so don't panic if that's what you got. Okay, so angle A, 78.4 degrees, 78.4 degrees. You can get a decimal degree, that's just fine. Only thing I'm missing now is side C, but guess what? That's 40. That's 78.4. I'm just missing one. I could use the law of sines. I could say sine of 40 over 10.5 equals the sine of C over 10 kilometers. I can do that, but it's actually a little faster to just use my calculator and say 180 minus the first angle I know, minus now the second angle I know, and I get 61.6 degrees. So that is angle C, 61.6 degrees. And now I've solved the triangle. 3 parts were given to me, and I used the law of cosine first to get the opposite side. Then I used the law of sine second to get that. And then I used the sum of the triangles to get that one. So I had to mix and match a lot of different rules. That's going to be pretty typical for these. Generally, you don't want to use the law of cosine more than once because it's a really long formula. You use it once to get you started, and then you finish it with the law of sine, which tends to be a little bit simpler. Okay, so I'll do one more example, and that's going to be number 9. Right? So we're going to work out number 9. Now for number 9, we need to draw our own triangle, and all we know are the sides. So we're going to draw the triangle. Have angle A, B, and C, and I don't know any of them, but A is 6, and A is across from angle A. B is 8, and C is 12. Now, some of you who are really clever might be like, isn't that a Pythagorean triple? If it isn't one of these angles, it's not, because this would need to be a 10. Right? And if you don't know what I'm talking about, don't worry. This is not a right triangle, as it turns out. I'm going to copy this triangle onto my own notes, so I have a little more space to work. So A, B, C, 8, 6, and 12. Okay, so this one's a little bit trickier because I don't know any. I don't have any pairs. I don't have any partners with A and 6. I don't have any with B and 8 or C and 12. There's no partners, so the law of sines is not going to work here. So I have to use the law of cosines. I know all 3 sides. I don't know any of the angles. So actually, I can solve for A or B or C. It kind of Doesn't make any difference. There's no advantage. I will try to solve for A first just because it's A. Right, it's the first letter of the alphabet. That's my only reason. You could solve for B or C. Right, so I'm going to try to use a law of cosines. The law of cosines says that the side, now since I don't know A, its partner is 6, so 6 squared equals the other two sides, 8 squared plus 12 squared, minus 2 times 8 and 12, times the cosine of A, which is the one I don't know. I know all the numbers except that one. Now this is going to be a little more unpleasant. All right, so I'm gonna have to work all this out, and I'm gonna do this in a couple steps. All right, 6 squared is 36, 8 squared is 64, 12 squared is 144, and then I'll do a calculator for negative 2 times 8 times 12. That's gonna be negative 192 times the cosine of A. I just multiplied these three numbers together to give me 192. It's negative because it's on negative 2. Right? Now I can add these two numbers together. All right, so 64 plus 144 is going to be 208 minus 192 times the cosine of A. Now, once you get really good, you can sort of combine these steps together, but I'm doing them slowly. You can kind of see. Now, some students would say, well, 208 minus 192, but it's 192 times the cosine of A. So these PEMDAS backwards says these have to wait. So the next thing you have to do is minus 208 from both sides. All right. I can't minus it. That would be like saying x. I'm sorry. That would be like saying. Side note, sidebar. The reason you can't do 208 192 times cosine of A, that would be like taking 8 minus 2x and saying, oh, well, 8 minus 2 is 6. I'll just get 6x. You can't do that because 8 and 2x, negative 2x, are not like terms because it's 2 times x. The only thing negative 192 cosine A can subtract with is another number with a cosine A attached to it. There's no cosine A here, so they're not like terms. All right, so that doesn't work. So all I can do is minus 208 from both sides. So I'm going to do 36 minus 208 and get negative 172 equals negative 192 times the cosine of A. I'm trying to solve for cosine of A. So I'm just doing all the kind of messy algebra I can until that's alone. And now to solve for that, I need to divide both sides by negative 192. That's going to cancel. I'm going to get the cosine of A equals whatever that is. I'm going to need my calculator for that. So now I know two negatives cancel. I'm going to be positive, so I'm not going to worry about that. So I'm going to do 172 divided by 192. I'm going to get this decimal 0.8958, rounding it off. I equals the cosine of A. Now, I can't divide both sides by cosine, we did before, but the opposite cosine is the inverse cosine. So I'm going to take the inverse cosine of both sides. Inverse and cosine, that cancels. So I have to do the inverse cosine of, and I'm going to use the answer, so I don't have to round it, and it gets me 26.38, so I'll round it to 4 degrees. All right, so I have to use the inverse cosine button at the end. So I'm trying to solve for A. The only way to get rid of cosine is through the inverse of cosine. And I kind of have to do it at the very last step. All right, so now I know angle A is 26.4 degrees. So that one I do know now. All right, so I did all that with the law of cosines. Now I still need to figure out angle C and angle B. Still don't know them, but wait, thanks to all this work with the law of cosines, I have a partner now, right? And I know the partner of A. So if I'm missing B, I can say that the sine of 26.4 degrees over 6 equals the sine of, and I can either go for B or C. It doesn't actually make any difference because I know B's partner and I know C's partner, so I can pick either one. But I'll pick the next one in line, B, over 8, because B's partner is 8. And then I just do this like before, right? Multiply both sides by 8, work that out on my calculator. All right, so 8 times the sine of 26.4 divided by 6. I get 0.5928 equals a sine of b. Actually, I'll do it right here so you can kind of see everything I did. And again, the opposite is I have to do the inverse sine of both sides. So then that cancels. So b is going to equal the inverse sine of that answer. And so that is 36.3 degrees, approximating. Just go to the nearest 10th. So there's my answer for B, 36.3 degrees. I'm running out of space, I'll have to fake a little bit. There's that angle. And then the last good news is now that I know these two angles, I can just use the sum to get the third one, because angle C is going to be 180 minus 26.4 minus 36.3, and that is 117.3. All right, so angle C equals 117.3 degrees. So now I have found all three angles of the triangle and I've solved it. Now you don't have to do it in this order. You can do it in various orders, but you did have to start with law of cosine to get you going. Once you use it, that's usually enough to give you a partner, and then you can use that partner to finish the rest of the triangle with law of sines or the sum of the angles formula. If anything, as soon as you know two angles, you can get the third one just from the sum of the angles formula or theorem, whatever it is, okay? So if you need further examples, there's more in your book, and I also linked to our website that has further examples, okay? So I hope that helps you out, and if you need help, stop by my office hours.